Lesson 1.4, dividing complex numbers. We need to know what a conjugate is. We've talked about this before. Conjugate is when you change the sign between the two terms in a complex number. Okay, so on this first example, -4 plus 3i, the conjugate would be -4 minus 3i. We never want to change the sign in front of the first term. And then the second example just has fractions in it, but see how it's still an a real part, and then the bi, imaginary part. We would want to change the sign between them. So it'd be 1/6 plus 5/6 I. Now that we know that, we'll be able to divide complex numbers. And again, we want to express our final answer in the simplest a plus bi form. When I have I in the denominator, that's a problem. It's kind of like square roots. They can't stay in the denominator. And the way that I'm going to get rid of I in the denominator is I'm going to multiply by another fraction that is the conjugate of the denominator. So 1 minus I would become 1 plus I. I'm changing that sign between the two terms. And I put it over 1 plus I. This is the same thing over itself. Anything divided by itself is 1. So I'm discreetly not changing the value because I'm really multiplying by a 1. Okay? And so I'm going to put parentheses around everything. That helps me see that I'm really foiling. So on the top, I would have 9 times 1 is 9. Outers would be a 9i. I don't know why I put a tail there. -1 times, negative I times 1 is negative I. Negative I times I is negative I squared. All right, on the denominator, here's the cool part. I'm having the same thing times itself. So look what happens other than the signs are different. 1 times 1 is 1. Outers gets a positive I. Inners gets a negative I. And then last gets a negative I squared. Do you notice anything that will cancel? The positive I and the negative I are gone. I squared, remember, is a -1. So what I've got going on here is I've got, let's go and fix this too. I squared here is -1. So I've got 9 plus 9i minus 1i is 8i. And then this was a negative times a -1, which is +1. Same thing on the bottom. Here's a 1. My i's canceled out. Negative that was here times a -1 is +1. Combine your like terms in the top. You get 9 plus 1 is 10 plus 8i over 2. When I taught in Algebra 2, when I taught you guys in Algebra 2, we left it a fraction most of the time and we just simplified it. Well, they're wanting us to actually split it up so that we have a real part and then an imaginary. So you don't want to think about ever leaving these with a binomial over a monomial. We want to divide 2 different times, which we did do that too because this one will divide nicely. 10 divided by 2 is 5, and then you want to divide positive 8i by 2, which is plus 4i. So that is our a plus bi form. But if this didn't divide evenly, you would still separate it into 2 different fractions. All right, let's try number 2. So we don't like I in the bottom. We would need to multiply by the conjugate of the denominator, -9 plus 6i, -9 plus 6i. Okay, I'm going to let you FOIL this one on your own. Here's what I got down to. Hopefully I did all my math right. I got 96 minus 51i over 117. And I also will note that usually I'll get to where on the bottom, I don't even do the outer and inner. I just multiply the first and last because I know these will always cancel out. And some of you probably did that. Okay, so what do you do from here to get an answer? Well, you can figure out if this has a common factor. You could divide out first or go ahead and split it into 2 fractions. We would have 96 over 117 minus 51i over 117. And then what I would do, since those are such weird numbers, is take my calculator and try dividing it. I mean, I know of course it's going to get a decimal, but then remember you go to math and then we want to turn it into a fraction, so hit enter, and enter one more time, and it reduces it for me. So 96 over 117 becomes 32 over 39, and then do the same thing for 51 over 117. And I got 17i over 39. So see how that still is the a plus or minus the bi term, and really I could go up here, or it could even go here after the fraction. So two different ways. Delta Math will take your answer either way you want to put it.